Hello everyone! Today I'll show you the process of creating a web application and tell you a bit about its technical side. Let's start with the very heart of any Node.js application, the package.json file. Let's see what dependencies we're using. As you can see for the UI, I've chosen Radix UI components. There's a whole set here, from accordions to tooltips. For the backend and database operations, Supabase is used. For server state management and working with tables, we have TanStack Query and TanStack Table. Of course, the project is built on Next.js. There's also an integration with OpenAI for AI features, Zod for schema validation, Lucid React for icons, and Tailwind CSS for styling. Overall, it's a pretty modern stack. I want to tell you a bit about the AI assistant that helps me with development. I'm using RuCode, integrated into VS Code. It has several standard modes, such as Code for code generation, Architect for design, Ask for general questions, and others. I've left most of the settings at their defaults as they work well enough out of the box. The only significant change I made is the role definition for the code mode. I set a custom system prompt so the AI better understands the context of my project and the specifics of the tasks when writing code. This is what it looks like. This helps in getting more relevant and high-quality results. Otherwise, as I said, I've hardly changed anything. At first, it seems the custom instructions didn't load, showing undefined, but actually, if we check the system prompt, all the rules and settings are in place. There they are, all the necessary instructions for proper operation. So everything is fine here. Essentially, I haven't changed anything else in the assistant settings. Everything else uses default values. Now, let's switch to Ask mode. We're going to set up the project and we'll start with the database. First things first, we need to create a database in Supabase. This will be the foundation for our future application. Let's quickly go over the project structure. Folders like auth pages and authentication-related files. This is standard code that comes with the Supabase integration. I didn't write it. In components providers, we have standard providers for theming and for TanStack Query. Also part of the initial setup. The docs folder for documentation, lib with utilities, for example, utils.ts for general helper functions. In the types folder, there's a supabase.ts file. TypeScript types, based on our Supabase database schema, will be generated here. I also haven't touched the utils/Supabase folder. It contains helper code for interacting with Supabase, provided by the integration. And finally, the .env file. Environment variables are prepared here, which we'll fill in as we configure the project, API keys, URLs, etc. So that's basically the entire basic project structure we'll start working with. In the rules.md file, we have general rules. You can see them here. This instruction file is used for all assistant operation modes. Perhaps these general rules are better suited only for Ask mode, and for code generation, there's a separate file, rules.code.md. Here are the rules used specifically for writing code. I generated some of them and added some myself. It specifies how to use Supabase for server and client operations, authorization, and where type schemas are stored. It's also noted that all Shad CN UI components are already installed. An important rule, for correct server-side code generation in page.tsx, parameters should be passed as await params. This helps avoid constant errors. Next, I've specified that when creating the interface, the docs/architecture.md document should be followed for visual customization and overall structure. I also pointed out that to implement chat functions and interact with AI, the AI SDK should be used. These are the main points regarding rule setup. Now let's look at the initial project. In the browser, it's just a blank home page. There's nothing else. Next, we need to create a project in Supabase. This is done very easily. Let's name the project RAG. We'll specify the server region. The closer the server, the better the performance, but for general access, a more distant one can also be chosen. I'll select Frankfurt. Click Create New Project. The project is being created. Now let's go to the project settings to the API section. From here, we take the Supabase project URL and paste it into the next public Supabase URL and Supabase URL variables in our .env file. Next, copy the anon public key and paste it into next public Supabase anon key. We'll also need the service or role secret key. Copy it and paste it into Supabase service key. This key will be used, for example, when working from a Docker container to perform operations with elevated privileges. I'm also duplicating the URL from next public Supabase URL into Supabase URL, as this variable might also be used in a Docker environment. The host folder variable points to the local folder c:/local-documents, where files for scanning and indexing will be placed. The OpenAI API key will be used to break these documents into chunks and create vector embeddings in Supabase. Essentially, this completes the basic setup of Supabase and environment variables. Nothing more needs to be done. Everything should work. Next, the docs folder. The main document here is architecture.md. This is a fairly large file, around 180 lines, which describes the architecture of the entire application. I generated it using ChatGPT. I simply described what kind of application I want to see, what it should do, and ChatGPT created this structured document. It's needed so the AI assistant can better understand the task. This document also describes how file processing will occur, for example, creating a separate extensions table for parsing rules for different file types, but this is for more complex future functionality. The chunking process is described. Overall, this is a detailed plan that can simply be read to understand how everything is conceived. Also in docs is an empty todo-progress.md file, which will be filled with tasks during development, and the first prompt.md file. This will be our first prompt for the AI assistant. It tells the assistant, first, read the entire docs/architecture.md, then create a todo-progress.md file in the docs folder based on architecture.md. Here's an example, todo. Okay, we can start creating the application, but before that, first the user needs to be able to authenticate. Here we have the sign-in page, and here's the sign-up page. First, we'll register, and then log into the application. After authorization, the user lands on the main page, which is currently empty. Also, before we begin, we need to remember to take our Supabase project ID from the .env file and specify it in the rules.md file. This is so the AI assistant understands which specific Supabase project it will be working with. Now that everything is set up, I'll copy our first prompt from the first prompt.md file and send it to the AI assistant. We'll close the other files for now, and let's begin. In theory, everything is ready for generation. The AI assistant starts working. First, it reads the architecture.md file, then checks the .env file for the necessary variables. After that, it proceeds to create the todo-progress.md file based on the architecture and using the specified format. There it is, starting to generate todo-progress.md just as I requested. After that, it moves on to creating the main chat files, ChatPage, Sidebar, and ChatArea. Let's see what it has created. The files are appearing in the project structure. Excellent, all three main chat files have been created. It's important that the chat is created using the AI SDK. Then my prompt will work correctly, and the assistant will do everything right, generating a streaming response and using the necessary components. The AI assistant has created the basic structure for the chat page, including ChatSidebar and ChatArea. It has also updated todo-progress.md to reflect the creation of the chat page and its main components. It suggests running the npm run dev command. Since my project is already running, I won't execute it. It says it has created the initial structure for the chat page. Let's check the created files. In page.tsx for the chat, there are import errors. It can't find ChatSidebar and ChatArea. Let's restart the TypeScript server. Sometimes it doesn't immediately see new files or changes in imports. Yes, after restarting, the errors are gone. Now let's go to the browser and look at the /chat page. This is roughly what our chat looks like. This, of course, is not the final UI. We will change all of this, but the main thing is that there's some initial structure. Sessions are displayed. Basically, everything is created. Next, we'll need to move on to implementing the rest of the logic. All right, let's see what we've got here. Essentially, it just created placeholders for the chat components. There's no real logic here yet. Here's the page for the chat and the ChatArea and ChatSidebar components. In ChatArea and ChatSidebar, it's currently mock data. This isn't what we ultimately need, but it's a start. Now let's take the second prompt. I'm telling it. Start by implementing chat sessions and the chat itself with database integration. Use AI SDK to build the chat. For state management, use the page URL. For example, the chat session ID. This is good practice for Next.js, sending the prompt. The AI requests access to Supabase to get the project ID, even though I already provided it. Okay, let's confirm. It creates migrations for the chat sessions and chat messages tables, and then generates TypeScript types for the Supabase schema. Great, the types for supabase.ts are populated, and todo-progress.md is updated, reflecting the database setup. Now it's starting to implement the chat functionality. First, it will create an API route in Next.js to handle chat interactions using the AI SDK. This route will receive messages from the client, interact with the OpenAI model, and stream responses back. Here, the app API chat root file is being created. Looks like there are TypeScript errors, missing dependencies AI. It suggests installing them, running dependency installation. It installs them all by itself. Now we need to fix the imports in the API root and issues with streaming text response. Next, it will update the client-side components. ChatArea will use the AI SDK and the useChat hook to interact with the API. The AI updates ChatArea and ChatSidebar. It fixes errors, adds logic for loading and displaying chat sessions, message history, and saving new messages. It notes that ChatSidebar will need to explicitly refetch sessions after their creation or deletion. The code, of course, isn't exactly how I would write it, but for an AI, it's not bad. Let it be for now. We can refactor later. The AI continues to fix the code, dealing with type errors in route.ts and ChatArea. The todo-progress.md file has been updated again. Let's go to the browser and test the chat. Create a new session, send hi, the AI responds, refresh the page, and yes, the chat history now loads correctly. The problem is solved. Basically, what I needed has been done. The core functionality is working. Refresh, delete a session, create a new one. Everything updates as it should. Chat history is preserved after a reload. Excellent. Now I'll write to it to fix these two problems. UI not updating for sessions in the sidebar and message history not being saved. Although it seems to have done this already, I'll formulate a clear request. It suggests solutions for the sidebar. Double-check useEffect dependencies or use an explicit fetch sessions call. For message history, save on both client and server. The AI starts implementing these fixes. First, saving user messages in ChatArea.tsx, then assistant messages in API chat route.ts, and loading history in ChatArea. It's fixing type errors again, using core message from AI React. The code doesn't look exactly how I do it, but the main thing is it works. Let the AI handle this. I'll remove unused imports myself later. That's just my nitpick. todo-progress.md is updated again, reflecting all the changes. Checking in the browser, the chat works, sessions are saved, message, history loads, everything is great. The AI fixed everything and updated the task list. Now I'll just go through the code and remove unused imports. This isn't strictly necessary, but I prefer it this way to keep the code cleaner. Okay, let's continue. I've created the third prompt here. Here I'm asking the AI to refresh its memory using the docs/todo-progress.md file and to start implementing the crawler service. It should run in Docker, monitor a local folder, and on any changes, adding, removing, editing files, add them to the Supabase vector database. It's important that a file isn't reindexed if it hasn't been modified. Sending the prompt. The AI first reads todo-progress.md. Then it proposes a directory structure for the crawler and creates the initial files. The AI mentions the need to enable the PG vector extension in Supabase and create files and chunks tables. After that, it switches to code mode to create these tables. Now it confirms the extension is enabled and the tables are created. Next, it describes the crawler Docker file and requirements.txt files. It created crawler.env example. Now we rename it to .env and fill in the variables. I'll copy Supabase URL, Supabase key, OpenAI API key from the main.env. We'll take test user ID from Supabase. Let's run it. The Docker image is building. The crawler started, but there's an immediate error. Local documents folder doesn't exist, stopping the crawler. Let's ask the AI to analyze the logs and fix it. The AI confirms the issue is with the watch folder path and suggests fixing Docker Compose to correctly map the local documents folder to /data inside the container, and also to check crawler.env. The crawler started, Supabase client initialized, file processor launched, file system observer started. Now let's copy our todo-progress.md into the local documents folder. The crawler immediately detects the file, parses it, creates chunks, and successfully adds 13 chunks to Supabase. Okay, the crawler is set up. Now let's whip up an MCP service to connect the database with the agent. I recopied the .env settings for the Docker file of the MCP service. At first, the AI didn't understand me and started doing the wrong thing, so I had to stop it and give a more precise prompt. I also ran into an issue that took me a while to figure out, but it turned out to be my fault. I had deleted the OpenAI API key from the .env file. After I restored it, everything started working again. For a simple test, I created a text file with a fake password. Let's write a Google password. The assistant should find it in the Supabase database. Great. It found the password and provided the source where it was found. Let's try again and ask the assistant for information from the todo-progress file. The assistant replies that it doesn't know anything about the crawler. This is not actually an error, as it might seem at first. The issue lies in the settings for how embeddings are created. The higher the match threshold value, the lower the priority of the information found in the files. In other words, the assistant will require a more precise query. I lowered it to 0.3. These settings can be experimented with. Let's ask a question about the local folder AI project. Or let's ask a question about the crawler, whether it has been implemented. Great, we can now consider the initial task completed. Now I can place a file in the folder, and it will be instantly indexed and immediately stored in the database. When I send a message to the assistant, it is first sent to the MCP service, which queries the Supabase database. The database instantly returns relevant results, which are passed to the AI. The agent analyzes them and provides a response to the user. As a final step at this stage, I suggest improving the design and code of the application. I noticed that the AI didn't use TanStack Query, even though it's specified in my instructions. I'll probably need to revise them. Let's instruct the assistant. Update all component styles used on the ChatPage. Enhance the visual design. Apply TanStack Query for data fetching and loading state indication, and perform a light code refactor. Improve the chat UI UX as well, especially the display of additional information about sources. Great, it looks good. An error has appeared, but it's easy to fix. Just copy the stack trace and send it to the assistant. Here are my takeaways. Using Gemini 2.5 Pro directly via API key is very expensive. It's better to either use Gemini Flash or work through Windsurf or Cursor. If this video format is interesting to you and you'd like to see more, I'll continue developing this project in the future. Add new features and dive deeper into embedding creation and other aspects from the main architecture file.